Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 2 from section 9-1 from the SavvasRealize Algebra 1 textbook. The goal of today's video is to solve quadratic equations using tables, which is the absolute 100% worst way ever to ever solve one of these problems. Ever. So I'm going to show it to you. And then I expect for you to immediately forget it because this is absolutely terrible. So here we go, let's do it. So on many graphing calculators, you can, this is modeling a TI, you can take an equation and you can write it into a graphing calculator. And what you can do is you can pull up a table of values on your graphing calculator. And it'll just plug in 1, 2, 3, 4, 5, 6, right on into there into your table. And so if you look on that table and you figure out where y equals 0, it'll give you your x values, and those are your solutions. So here on part A, the solutions are x equals 1 and x equals 6. And sometimes that's okay. So for example, it says, how can you use a table to estimate the solutions of this one? And so take a look at their table of values that they've got going on here. Now, one of the solutions is fine. One of the solutions is here at -2. Now, this is not a perfect square trinomial. So you know that if there's one solution, there has to be a second solution on this. Okay? If this was a perfect square trinomial, you'd only have the one solution. So what we need to do is we need to figure out where the heck another solution's at. So let's check this out. Let's kind of think about this. So it goes from 0 to some negative numbers, and then here it's back to being positive. So right here where I'm coloring yellow, there's some kind of issue because it goes from being negative to being positive. That means that you know that between x is 0 and x is 1, you know that you have a 0 somewhere. Alright? So what we need to do is we need to do what's called refining the interval. Alright, so I know somewhere between 0 and 1, I have a solution. I just don't quite know exactly where. Now, on many graphing calculators, you have the ability to kind of zoom in even further on your table, or to change how your x values are being counted on your table. And so that's what Savvas does, is they zoom in a little further on this calculator. And so here they broke it up into quarters. Now again, there is no y equals 0, but it gets us a little bit closer. So you could see that it's changing from negative to positive between 0.25 and 0.5. Alright, so depending on how exact of a solution that you need, we can ballpark it and say, it's between 0.25 and 0.5. So I'm going to say between 0.25 and 0.5. For my other solution, I mean, that's not how Savvas notes it, but that's how I can write it without having to put a whole sentence on there. But like I said, this is why tables of values suck, because it's not getting you an exact solution. It's kind of ish, and you have to keep hunting for it. I don't like that. Alrighty, so now I have the feeling this is 0.3, by the way. Anyway, it doesn't matter. So now we get to our try it, right? And our try it is, it's asking us to use a table to figure out this value. Now what sucks is they don't give you a table for the try it, so we're going to generate our own. And so I want to show you an easy way to generate your own on Desmos. So the first thing that we're going to do on Desmos is we are going to type in our equation. Now, their equation, see how it says equals 0? We don't quite want that. I'm going to say like y equals or f of x equals, and then just the quadratic part of it. We don't want the equals 0 on there. So there is our parabola. So now for our table of values, all the values that I want to test, I'm actually going to type over here. Okay, so I'm going to start with -2. And notice it gives me a little slider bar, which is nice. And I can click to see where they intersect. So at -2, this function equals 3. And I'm just going to go through the whole numbers real quick, and then we'll split it up a little bit. So then what about at -1? Well, at -1, it's intersecting at -1, -6. So definitely a 0 in there if I just had this table of values, right? If I plug in 0, I get -7, which we should know that just from looking at the equation, right? Because that's your y-intercept. And then if I plug in a 1, ooh, it happily lands at 1, 0. So x equals 1 is definitely one of our solutions. And so now somewhere between -2 and -1, we have an intersection, right? An intercept. And you know this because it's going from a +3 to a -6. So for our y values to go from a positive to a negative, it has to cross 0 somewhere, right? So this is where we kind of try to zoom in a little bit. And I'm going to do kind of what Savvas did in that I'm going to split it like into quarters. So I'm going to do, oops, wrong tool, Missy. So I'm going to do -1.25, -1.5, -1.75, and kind of hope that that ish gets me there, okay? So let's start with -1.25. So when I do -1.25, I get -4.5. So that is not our solution. However, it does mean that our 0 is higher, or I should say lower than -1.25. So I'm going to keep trying it. So now let's try it with -1.5. So at -1.5, our value is -2.5. So we're getting closer to the number 0, but we're still not there yet, okay? Now another thing worth noting here, do you see how at -2 it's 3, and at -1.5 it's -2.5? So these are almost equidistant on either side of our x-axis, right? Like 3 might be up here, -2.5 might be here. They're about the same distance. So I'd imagine that pretty close to halfway between these x values would get me that 0 value. Okay, so that's why I'm trying -1.75, not just because I'm doing quarters, but because it's halfway between those. And sure enough, that -1.75 gets me my 0. So there is our other solution. So there we have it, guys. That is how to solve quadratic equations using tables. Again, this is not a good way to solve quadratics. It works sometimes, but 99.9% of the time, it doesn't work. Until next time.